What's going on, everybody? This is Mr. Diamond, here to make you mad at me by showing you a shortcut to a problem that I assume a lot of you have already done. Or, if you are the type of person who does not do your log yet, and you just noticed this one first for some reason, congratulations, you're about to learn a shortcut. So the problem that I'm talking about here is the one involving nitrogen monoxide. Now, in this problem, I'm going to jump to a point where I kind of assume you already know and got to in that problem. So first, I assume you got the balanced equation. We know that it's nitrogen gas into gas plus oxygen gas plus O2 gas. It's reversible, so do the correct arrow, Mr. Diamond. Do not screw that up. And then two nitrogen monoxides that are a gas. So I assume you guys got to this point of this equation. I also assume that you guys figured out that because it is in a 2-liter cylinder, you have to divide your concentrations you're given by 2. So to set up our ice table nice and clean here, we would get a nitrogen concentration of 0.085 moles, and you would get an oxygen concentration of 0.038 moles. And we know that there is no nitrogen monoxide at the beginning. Now, going through this like a normal problem, you do your minus x because there's a 1 there, you get minus x because there's a 1 there, you do a plus 2x because there's a 2 there. We get 2x, we get 0.038 minus x, and we get 0.085 minus x. And this doesn't seem that weird based on anything that we've been doing. Right now, the only thing that's really odd is that our KEQ is really tiny. So our KEQ is 4.2 times 10 to the negative 8th. And if we set this up, we know that we should have this value squared on top. So you'd have 2x squared over, we get 0.085 minus x, and then we get 0.038 minus x. And here is where the problem becomes a lot different than the ones that we have been doing. Most of the problems that we've done, in fact, all of the problems that we've done so far, you've had the same value, like something squared on top or two of the same value on top, and then the same values on bottom. So we could take a shortcut by doing a square root on each part of the equation. That made our algebra way easier. This one does not do that. And because this one does not do that, you end up having to go down a really awful rabbit hole that I was letting you think you had to go, although if any of you emailed me about it, I believe I told you to wait for today's video to show you why you could do it easier. Because from here, what you're going to have to do, if you just work this out, is... Well, first we're going to have to FOIL this equation. We're going to have to do, if you don't remember the FOIL method, that's first, outside, inside, last. So you do the first things, the outside things, the inside things, and the last pieces together. And from there, it only gets worse. Like, you're going down a... Okay, I got it kind of worked out over here. So FOILing it gives you, at least for the bottom part, if we FOIL that out, you get 0.00323 minus 0.123x plus x squared, and then that goes on bottom, which we then, to get x by itself, we're gonna have to multiply that to the other side, and you get like I'm just gonna show the work. I assume some of you might have actually already done the work. So let me fold this over because I really don't want to redo it. It is so many decimals. But basically you solve for and you get this number or this value that you FOILed out. You multiply that to the other side, so you have to distribute this really tiny number to it. You get all these really tiny numbers. You move them back over here, and you get 4x squared plus this really tiny number minus this really tiny number. Or what you might have done was you might have moved these numbers back over to this side. If you did that, your life was way easier. But I'm just assuming that you get this over here, and then you're like, oh, I only have to move one piece. But that actually, you really probably should have wanted to move the other pieces. I guess not move the other pieces, but anyway, regardless, it'll make a little bit more sense later on. So doing it this way, you end up with this problem getting it into our ax squared plus bx plus c, and that equals 0. And then we have to plug that into our quadratic formula, a negative b plus or minus the square root of b squared minus 4ac all over 2a. And the two values you get are 5.82301 times 10 to the negative 6 and negative 5.8243 times 10 to the negative 6. We should not be getting a negative value for this because obviously we're going down. Negative value would mean we'd be creating more of this, and that's not what we're doing. So this is the value we go with. We multiply that by 2, and we get our 1.06 times 10 to the negative 5th. Now that's what you could have done. However, notice that these values here are like really tiny, like super duper tiny. And in fact, that the reason for that is because this number, our KEQ value, is like super small. And if your KEQ is much greater, we do two of the greater than signs, than your initial concentrations, we can take a shortcut. And I'm sure some of you are very excited about that because shortcuts are awesome. Because these values are such a small amount of change, so they're just such a tiny number, it's basically like it's the same. Now this shortcut can only be applied when specifically KEQ is 1,000 times smaller or more than lowest concentration. I'm just going to do the brackets to represent concentration. So if we multiplied this 4.2 times 10 to the negative 8th, let's do 4.2 times 10 to the negative 8th times 1,000, 4.2 times 10 to the negative 5 is still smaller than this. Even if we do 1,000 times this number, it is still going to be smaller than our 0.038 here. By comparison, if I write it over here, we've got our 0.038, and then we'd have our 0.00042. That is I totally was off screen. I apologize. That is a tiny number. That's very, very, very small. So what we can do, you get to ignore the loss of reactant. So small amount is going to be lost that we basically get to ignore that anything is lost at all. We know there's just going to be such a small amount of nitrogen monoxide made. There has to be some made, but the amount is just going to be so small that we can basically assume that this subtraction that we're doing is not actually doing anything. So the way we can set this up, instead of having to do the quadratic formula, foiling this and doing all of that stuff, we can instead set it up so that our KEQ, that is equal to 4.2 times 10 to the negative 8th, is equal to, we keep the top the same, it's still going to be 2x squared, but the bottom, we get rid of the minus x's. We just assume, well, the concentration at the end is basically going to be 0.085, because if we would have subtracted x from that bottom part, we would have gotten basically 0.085. And then if we do the same thing for the second piece, or 0.038, well, now it's a way easier problem to solve. Now, if we do some quick rearranging here, we can end up with getting the formula 4x squared, so that's just squaring this piece, and then if we multiply this piece to the other side, we get equals 1.3566 times 10 to the negative 10th. Divide that by 4. Square root of that whole piece. So 4's cancel, your square root will cancel that. And then you just solve for this value right here. This 1.3566 times 10 to the negative 10th. Divide that by 4. Square root that. And you get 5.82365 times 10 to the negative 6th, which, if I go back up here and we look at the number we got from doing our quadratic formula, we get 0.5823301. Now, it is different, this number and this number, but when we round to sig figs, I apologize for that. If you guys can hear that. I don't know if you can. I'm not sure if you guys could hear that. Someone was weed eating outside the window, so I paused it a little bit. But when we round these to sig figs, our number, I believe, that we're looking for is going to be, let me double check back to make sure I got the right problem. Our answer only goes to, 2 sig figs. So, honestly, the fact that it messes up or it stops being accurate to the 5th place of the problem, or the 5th significant digit, well, our answer for both of them is going to be 5.8 times 10 to the negative 6th. And because that's what our value of x is, which, again, this is not actually the end of our problem because we then have to multiply it by 2, we would get the exact same final answer of 1.06 times 10 to the negative 5th. Now, I'm going to talk through that a little bit more because I'm worried I might have forgotten something because of the noise outside. All right, I believe that the grass has successfully been decimated, so we can continue. Like I was saying, I want to re-explain this just to make sure, in case I missed over anything because I got distracted by that. So in our original problem, we thought we were going to have to subtract x. We get this value, you FOIL it out, you get this value, you do a whole bunch of crazy solving involving some quadratic equation stuff, and you would get these 2 values as your final answer after you put in all the work to do this and plug it into the quadratic. You get 5.82301 times 10 to the negative 6th. Because the question says, because we solved for x there, we were solving for x, we know our nitrogen monoxide is 2x. So you do have to double that, which would gives you 1.06 times 10 to the negative 5th as your final concentration of nitrogen monoxide. But notice that number is really small, and that makes sense because our KEQ value is super small. And if you remember, when KEQ value is a lot less than 1, that means that the reactant side is very heavily favored. And in this case, that means that you're going to keep most of your nitrogen and your oxygen. In fact, this one is so small because it's greater, it's either 1,000 times smaller or more small than that. It could be 10,000 times, 20,000 times, whatever. If it's 10,000 times smaller or more than the lowest concentration value, in this case the lowest concentration being 0.038, we can just ignore this change. This number is so tiny that it is an insignificant amount of nitrogen and oxygen that you're going to use in this reaction. So instead of doing this process, foiling it out, all that kind of stuff, we just ignore the losses. We say, well, if we subtracted like this number right here, if we subtracted our 5.8 times 10 to the negative 6th from this number, well, sig fig wise, we'd end up with the same thing. And the same thing here, 0.038 minus 5.82 times 10 to the negative 6th, two sig figs would be 0.038. It would be the exact same number. So we get to ignore those losses and only worry about solving for the x at the top. Now, rearranging this, you multiply these together, then multiply them over here times the 4.2 times 10 to the negative 8th. Then we have to, never mind. Divide that by 4 because 2 times 2 squared is 4, and then x squared would be the other piece of this. Divide 4 to the other side, square root to get rid of the squared that's on the x, and you would end up with x is 5.82365, which is slightly different than the value we got up or on our other problem, which is slightly different than this one. But it's not enough that the sig figs will matter. Once you account for sig figs, it's going to be the same number, give you the exact same value, 1.06 times 10 to the negative 5th molar of nitrogen monoxide. So I'm not going to do any problems that require you to do this shortcut in this class, but if I give you a problem like this, I would always go back and double check and keep this in your back pocket because you can use it for any of the problems that I give you. You are allowed to use it. I will just never make a problem that requires you to do it, at least not on a main test. Maybe on a bonus question or something like that. I hope that makes sense. I apologize if I had to repeat myself a couple times. Like I said, there was someone mowing outside, and I didn't want to try to talk over that, and I got a little distracted. But I hope this helps. I hope you're not too mad at me for me hiding this secret technique from you. I just wanted to make you guys do at least one quadratic. But have a good rest of your day, and I hope to see/hear from you soon.